Hi, I'm Staś. I work for Mozilla, and I'm here to talk about the future of JS that already has happened. So I wanted to talk about the new features of ECMAScript that are already available to us and that most of you probably have heard about already. But I don't want to focus on the new syntax or the semantics, really, because I'm sure everyone here has already seen a lot of presentations about the new syntax and read a lot of articles. What I want to focus on today is practical use cases for these new features. So I've had a chance to work with new JavaScript for the last couple of months, and I feel like it's a great opportunity for all of us to have this discussion about how to actually use these features. So that's my agenda here, and I'm open to all suggestions and your questions, so please feel free to raise your hand whenever you have a question or an idea, because I really want this to be an invitation for a discussion. I'm not saying this is like the only viable way of doing things. This is what I've seen or what I did, but or what I have done, but like I'm sure you guys have equally viable experience. So let's have this conversation together. So again, this is not about new syntax. Everybody knows arrow functions, and I'm really happy because in past presentations today, many of you have already used arrow functions. So hey, we all use arrow functions, and it's less typing. But it's not only about typing, right? Arrow functions allow us to avoid the bind, which is slow and cumbersome. So you know, always a good thing to use. But most importantly, arrow functions have lexical this. And again, who knows this? Who knows about lexical this? Just a quick show of hands. Okay, so that's around 1/3 of a room. Lexical this means that you no longer have to do the upper thing. You don't need to do the bind operation on your function inside of for each or inside of a map or add event listener. You can just use the arrow function, and the this in here. Oh, I really screwed this up, didn't I? The this in here is the same this here is the same this as this here. So that's really this really makes your code easier to read and write, and everybody should use arrow functions when needed, when possible. Okay, next, let and const, block scoped variables. Who knows about block scoped variables? Great. I'm going to make you exercise a little bit, because I have this trouble with this presentation. It's called the curse of knowledge. Like, if you know something, you think that everybody knows that. And like speaking to this crowd in particular, I realize that you are very knowledgeable people. So like I don't want to talk about the obvious things, and I'm sure some of these things will be obvious to you, but I still wanted to point out a couple of gotchas or ideas that I had about these things. Okay, so the general rule of thumb that we've been using in Mozilla is to never use var at all. Because you don't have to. You can use let when the variable in question needs to change, but really, whenever we can, we try to use const, and it works really well. In fact, I've taken this a little bit further, and every time I realize that I can't use const, I start to think, maybe I should rewrite this function. Maybe there is a way that I don't need to use let. And this helps with testing, this helps with predictability, because I can't really change the bounding that I created with the const statement, and it's really great. So again, if you can, try, as an experiment, try using const wherever you can, and if you can't, use let, and then think maybe you can use const and rewrite the function. Okay. Let is great, though, because you can use it in for loops. And this is an example of a code that probably every one of you has written at some point of your life, and it has bitten you quite badly. Does anyone know what this code does or what it doesn't do? Where's the bug?
Variable will be always the last.
Exactly. So the A variable is bound to the last element of the array, and that's because var binds by the functional scope. Let, on the other hand, I let change there, creates a new binding in every iteration of the loop. So you don't have to worry about this famous JavaScript gotcha anymore because it just works the way you expect it to work. So that's great. Here, the A variable is a new instance of every time the loop runs, and so you don't have to worry about it at all. Okay, by the way, in the last example, I used the off operator, the for off loop. That's really handy for iterating over collections. I'll get to that in a minute, but just wanted to point it out. You can use the off operator to iterate over arrays, sets, node lists, and a couple of more. It's really handy and iterates over values, not keys, as the for in loop that does. Okay, let's move quickly to the other one. Object property shorthand. So a lot of features of ECMAScript can be summarized as things that allow you to type less. And that's already great because I don't have to type foo twice if I know that I'm returning an object with a property named foo, and the value of this property is also foo. That's easy. So in ECMAScript, you can just do this here, and it knows to do the thing right. But when is this actually useful? So for one hand, it encourages you to write code that it's easier that's more readable, really. So if you name your arguments right, then you can pass them through without changing their names. And what it really does is it allows you to write code, or maybe let your data flow through code in a more or in an easier manner, or like you don't have to manipulate that data too much in terms of naming and stuff. So here, for example, the argument is key, and the search criterion also takes a key argument, right? So that's really easy. All this does is behind the scenes does this, right? I mean, it's pretty obvious. But the other way this can be used, and I use this quite a lot, is when I return from functions. So sometimes I will be tempted to return an array. Sometimes I want to return an object. And it gets tedious when you return an object whose values are named the same way as properties are. With object property shorthand syntax, you can just type this. So you construct an object literal with name and type in this example, and it does the right thing. So it makes your code more semantically meaningful to whoever consumes it. However, with new features of ECMAScript, you can actually still use arrays to great effect. If you return an array from a function, like in this example here, you can use the Destructuring assignment to semantically deconstruct the array that was returned. So in this example here, I'm calling the function foo, and I'm assigning its contents to a locally bound variable's name and type. This allows me to have better reasoning about what the code does. I start right away with the right names, and I don't have to do all this really weird thing when which takes 3 or 4 lines when I have to assign to result and then take result.name, result.type. So this is really convenient, but also I feel like it makes the code better and much more readable just by the nature of being shorter. Okay, there is this joke that I heard a couple of months ago that there are 2 kinds of JavaScript developers. And the first kind does the first line, and the second kind does the second line. So this is the structuring assignment of objects. You can either you can get the property from the object, or you can destructure the object into a property. This also looks a lot like import statements, and that's not coincidence. They were designed to look similar, although they're not entirely the same. So how can we use that? Well, the structuring assignment is great when you don't need all the objects or properties. You can selectively take just a couple of the properties that you need in this piece of code. You can also get deeper. These can be nested, so you can get something from a nested structure easily, and you don't have to repeat the whole dot operator accessor thing. You can also use it in loops. So you can easily assign inside of a loop a variable that's pointing to a property. So again, this makes your code easier, and it works great with the for-off operator, which I'll talk about in a second as well. Okay, destructuring in loops can also make this kind of pattern easier. So here, this is a little bit of abstract, but you can imagine, for example, an array of arrays, like here, and the first item is a method name, and the second element are the arguments to this method. So in general, what I think ECMAScript allows us to do is to use use tuples, really. So like it brings some love to arrays, and arrays can be worked with very, very cleanly and very easily because of all these additional syntax sugaring that now we have available to use. Okay, and probably the last example here, or not really last, but related to destructuring is the destructuring in function arguments. So in here, I have this object, which has a couple of properties, but crucially in this line, I'm using the code variable that's taken directly from the object. So again, just looking at the fetch resource function in this example, I can clearly see which kind of data I will need. And I don't really care about the other properties in the lang object. So this, in fact, can be any other object. What only matters is the code property. So this makes your code also more extensible and more composable. There's a question.
Does it pass the reference to the value or the value? Like when I change the code inside this fetch resource function, the code, will it change the object as well?
No, this is a new local binding, so it doesn't pass the reference. I mean, if you pass if code is object, I'm not sure if I understand really, but if it's an array, and here you will change it's a reference, but the code is a local variable. So if you overwrite it, it's not, right? It works like JavaScript. Okay. Destructuring and arguments can get pretty unwieldy too. So be careful. Here in this example, to be honest, I'm not sure which one is better. I kind of feel that the first example is actually more readable. So I think it's our responsibility to also not go overboard with new features, because sometimes the old way is actually better. So here, it's up to you, but you can deconstruct 2 points, like in this example. But then again, is it really better than this one? I don't know. It's up to you. Usually what I do is try to use destructuring or the default arguments and destructuring in functions for things like this. So there is an options object maybe that you pass to your function, but you just want a small subset of options to be set by default. Because to be honest, if you start adding more default values there, like the whole signature of the function gets really unwieldy and really big and long, and I don't even know how to indent that anymore. So something to take into consideration that it might not be the best idea to do if you overdo it. And also the semantics the semantics for default values are really weird too. So pay attention to it if you ever use it. In this example, there is a difference between x equals 10 and y colon 10. And the difference is, does anyone know what the difference is? No hands in the air. The difference is, and it's really weird, kind of makes sense though. The difference is if you, as a first argument, if you pass an object and it doesn't have x will be 10. In the second case, if you pass an object and it doesn't have y, the y will be undefined. And that's because y will be 10 only if you don't pass the second argument. So the part in this part here is about what happens if there is no second argument and not what happens when there is no y property in the second argument. So again, this is just a friendly warning, can be kind of weird, pay attention to it. Computer property names, that's probably my favorite one because it taps into the other one that I'll talk about in a second, object assign. But you can use computer property names if you don't know the name of the property up front. So in this example, foo is a variable, and the property will be named whatever foo's value is. Why is this useful? Well, you can use it with object assign to a great effect. Object assign is a new function available in ECMAScript that merges objects in a shallow way. So in this example, the new object will have both foo and bar, and you can use this with computer property names in just like in this example here. So what happens here is I'm reducing an array into an object, and I use object assign to do that. But so my array looks like this. It's a key value tuple. And in here, I'm assigning the key with the value. Does that make sense? OK. So again, object assign, a great new feature of ECMAScript. It can also be used for really nice composition. I see a question. Yes.
Actually, the object, OB,
yep.
variable, will be changed. So we're assigning this object. Because assign.
You're right. I should do this. Yeah, you're right. That's a great point. Thank you. It's a typo. Yeah, he's right. It's great. I wish I had any kind of prizes. I don't. Talk to me. I don't know. I'll get something for you. You're right. Object assign mutates the first argument as well as returns it. So here I only used it for return effect, but you're right. I should do this because it also mutates the first argument. It's a great point. Thank you. Save. OK, so object assign is great for composition. God, see, I did the right thing here. So you can provide these small components here that take some external state and return a small, tiny object with only part of the implementation or part of the interface. And then you can compose them with object assign into the real thing. So here I'm object assigning the jumper component into my player object. So again, this works great for composition. OK, I only got like 12 minutes with questions. Let's go. REST parameters and spread operator. A great feature, lets you manipulate arrays really easily. And again, this helps construct the flow of data in your program in a much better way. So here, this is just an example of what syntax does. I'm gathering all arguments passed to a function as a single array, and I can work with this array. Again, how is this useful? Well, first of all, no more this. Like, you don't have to do that anymore. Apply is way easier with REST parameters or spread operator. Same with constructors. In fact, you couldn't in the past. It wasn't able. You weren't able to use apply on constructors, and with spread parameters you can. You can do this. So I mentioned before that you don't have to do the binding, but if you don't know all the arguments, or if they're too long to spell out specifically, you can do something like this. So you can just gather all arguments on this side of the arrow, and then reuse them on the other side of the arrow, and that's actually great. No more this, so no more slice calls. You can easily convert a node list into an array by using the spread operator. Be careful though, because this doesn't work in Babel, because Babel assumes everything is an array and wants to concat things. But this will work at some point in Babel. You can easily push or unshift in a more declarative manner This is slower, admittedly, because especially if array is a pretty big one, but sometimes you care more about readability than performance, and if it's not a bottleneck, probably it doesn't matter too much if it takes, if it only can do 10 million iterations a second, or that probably doesn't matter that much, but it can have this nice effect of making your code more readable and more declarative as well. Here's another example that's arguably a little nicer than the old JavaScript way. So this removes an element from an array by building a new array with the rest parts from the left side and the right side. Again, works great, especially in this functional mindset that we've been seeing recently, where you probably don't want to mutate the old array, but you want to return a new one. So again, something to consider for you. Okay, promises. That's it's like, what is it? 75% of my presentation. Good. Promises are great. We all know promises. Promises are monads, as it was said today. That's a great point. And I actually have a little treat at the end of my presentation for those of you who are Haskell fans. But promises are great for storing state that can only change once in your application. So every time you have something that needs to load or be initialized, promises are perfect for this because you don't have to worry about them being initial, or you don't have to check for initialization as a semaphore. You can simply use the promise for this effect. So here in my text constructor, I have the loaded property, and everything I would want to do with text, I can just do in a then callback to the loaded promise. So that works great. I think it's a really nice pattern. You can use promise resolve as the unit function for promises. So every time there is a condition and you don't know if you're going to be returning something async or not, you can just use promise resolve to return an empty promise that will work great with the rest of your code that does then. And in fact, it's a much better idea to start your promise chain with a promise resolve rather than building a new promise with a promise constructor function. In fact, what I've seen is that you probably should never build your own promise constructor functions. Usually, the source of asynchronicity should come from somewhere else, or you should use promise resolve in your code. Okay, one of my favorite examples here, promise all. You can use map, which is here, map over an array of data together with promise all to get a nice array of promises, and then to resolve this top-level promise when all of these promises are done. So again, I feel like ECMAScript is great for using for each and map and all of these functional approaches that we seem to really like, because the syntax encourages this kind of thinking. So here I'm using map. I can also use reduce to resolve promises in a sequence. So in this example, I have the same source of data, same source of URLs, and I will be fetching them one by one in order. And I do that by reducing this array and building a new promise on top of the previous one in a sequence. And you can see how I use promise resolve as an initial value for this reducing operation. Promises are great also because they're fast. So they're not your regular set timeout asynchronicity type. In fact, they set timeout. If you imagine your code as a loop, the event loop, set timeout put things at the beginning of the next iteration, whereas promise then puts things at the end of the current iteration. So be careful too, because if you somehow manage to do another then call in a current then call, you can starve your CPU, and you can never. It is possible to never reach the next event loop iteration. And in this example, this is an anti-pattern. Don't do that. In this example, the yo will never get printed because you will starve the CPU. So just a friendly warning, be careful about that. Shit, 25 minutes already. I don't need to talk about that. Hey, maps and sets. Okay. Maps are great for records. So every time you have multiple things that have similar properties, perhaps it's a good candidate for map. Sets are great for arrays, essentially. You can quickly check if something is in a set, and they're unique, so that's also helpful. I'll talk about use cases in a second, but I wanted to really to focus on weak map and weak sets. So these two variations are like map and set, but they held their references weakly, and they are great for doing the following things. So weak maps are great for private data. If in this example, you can see that I'm building my objects, but certain properties of the object is not stored on the object itself. In fact, it's stored in a props weak map over on top, and it's only accessible from the scope where props is available, right? And this works great. You could extend this easily and have more properties here, and they don't leak into the outside world. They stay where you want them to be. Sets, on the other hand, are great for any kind of tagging you want to do. So in the previous example, if I were tempted to do something like this, I could just as well use a weak set and just add my object to a set of created things. This can work really well for two kinds of scenarios. One is whenever you're trying to detect a cyclic reference. And a lot of algorithms in general have this step where you need to check if you've already seen this object. So weak sets are great for that. And also they can be great for controlling whether or not subclasses can call your method or not. So in this example, I could have a method that checks if the object the method is called on exists in my object set, and then throw if it doesn't. If you subclass my object, then this object perhaps wouldn't be there, depending on the constructor. Okay, and lastly. No, not lastly, shit. Okay, ranges and symbol iterator, that's pretty cool. So symbols. Symbols are the new primitive type in ECMAScript, and they're a little bit weird and mystical, but importantly, they can be used for metaprogramming. So there is a list of well-known symbols, and symbol iterator is one of them, but there are many. And you can override default behavior of the engine by providing your own. So in this example, what I'm doing is essentially I'm adding the iteration protocol to the range class, whatever that is, with this, I can now use this as if this was a regular iterable collection. I can use for-off on it, for example. So any kind of object you have, it only suffices to add the symbol iterator method to it, and then it just works. You can iterate over it. The other well-known symbols are things like is concat spreadable, so you can define whether or not you can spread it or not. You can also override the default behavior for match and exec of regex objects, so that's pretty cool. Symbols are also great for defining unclashable methods, really. So if you recall my example from the composition with object assign before, in that example, the jumper component would create a method called jump on your object. But what if you use different components, and some of these names clash? Well, with symbols, you don't have to worry about that because symbols are always unique. So you can also export the symbol as the name of the property or the method, and then use that symbol like this. And this will be unique and unambiguous. And lastly, and this is the end, there was a great talk about monads today, and if you're interested in monads, I really recommend learning a little bit more about promises and how they implement the monad protocol. And if you're familiar with the do notation from Haskell, you'll notice that you can achieve something similar with ECMAScript generators. You can yield promises from inside one function into a function that handles the promise and then feeds it back into the generator. So that's probably, I'm over time already, am I? Yes, I am. That's really cool.